Hello everybody, so today I will talk about calculus. The topic today is the integral. We have the integral of sin x to the power of 3960 multiplied with cosine x to the power of 3961 dx. So I will show the technique how to answer the question. In here, we can separate the number 1 with the cosine x in here, because cosine x multiplied with cosine x to the power of 3960, you will return back to 3961. Next, we have the formula sin x squared plus cosine x squared equals to number 1. So we have cosine x squared equals to 1 minus sin x squared in here. So in here we need to convert the cosine x into sin x. We can put cosine x squared to the power of 1980, because 1980 multiplied with number 2, you got about 3960. Now we input about 1 minus sin x squared in here. Then we will use about integration by substitution. So you got about u equals to sin x, then du equals to cosine x dx. So we change this integral. Sin x to the power of 3960, you got about u to the power of 3960. This one change to u squared. Cosine x dx we change to du. Then we apply this formula. That's equal binomial formula. So in here we have 1 minus u squared everything to the power of 1980. So we got about the sigma. So in here we have k equals to 0, and on the top we have 1980 multiplied with the combination. So that's about 1980, and we have k in here. Then we multiply with minus 1 to the power of k, and we have u squared to the power of k. Minus 1 in here, that is from the negative sign next to the u squared. So now we input this one in this equation. Because we have u to the power of 3960 and we have u to the power of 2 everything power k, we can simplify this one. So we just simplify for the u. Now we can answer this integral in here, because c minus 1 just the number, so we just consider about the u in here. and we can answer the question. U to the power of 2k plus 3960. If we put the integral, we have plus 1, and in the denominator we have the same value of the power, and we put about c. Next, we know that u equals to the sine x. We change back to the sine x in here. And this is about the answer for the question. That's the end. Thank you for watching.